Hello, ladies and gentlemen. Let's analyze a ball going straight up in the air, but not just any ball. Actually, it's going to be any ball. All right. Read the example along with me. All right. We've got a ball is thrown straight upward and rises to a maximum height y above its launch point. At what height above its launch point has the speed decreased to 1/2 of its initial value? Okay. So, we want to know at what point above its launch point is its speed decreased to 1/2 its initial value. Like I said, this is the situation that's going to work for any object starting with any speed. Okay, so we're going to solve it all algebraically first. So here's our diagram. Ball goes up, comes back down. Now, we're actually not interested in this part of the diagram, although we'll see something we can glean from that a little bit later. Let us choose a reference frame. Again, all going up, coming back down. It's easiest to have upwards be the positive y direction and downwards be the negative y direction for us. This tells us the acceleration due to gravity is g. Now, because we're doing this all algebraically, we might as well leave that algebraically as well. Instead of writing negative 9.80 meters per second squared all the time and saying that, g. Sound good? See what I did there with the thumb up? Alright. Now, dang it, I Wested again. Alright. So there's some other things we know about this. We'll take the initial position of the object to be y0. We'll take the initial velocity of the object to be v0. Now, as always, we're going to need a basis of comparison here. And the basis of comparison is going to be the maximum height of the object, which we were told is going to be y. So let's find out just how high y is in terms of the other things that we are given. Okay? Well, we'll take an equation. Notice that time is not involved in this, so probably need an equation where time is not involved also. So let's look for one, and we'll find v squared is equal to v0 squared plus 2g y minus y0. Now y0 is very conveniently equal to 0, so we can just make it 2g times y. And if we're going to the very top, right, y in this case, that means that the velocity up there is 0. That makes the whole left side of our equation equal to 0. The whole thing is 0 in the end. At this point, we're going to solve it for y. So subtracting v0 squared from both sides, we end up with v0 squared is equal to 2g times y. Let's divide both sides by 2g. And we'll see that y is equal to the negative of v0 squared divided by g. Now, this is not yet the value that we're looking for. Remember, this is y, which is the maximum height above the ground that this object reaches. And in terms of v0 and g, this is what the maximum height is. Like I said, this is our basis for comparison. So now, we have to go back and we have to find out, okay, well, at what height, we've got a new height for y, right, a new y, we'll call it y1/2, because we're looking for y, vertical position, when the object has 1/2 of its original speed. Now again, we're going to start off with this equation here. There we go, okay. V squared is v0 squared. 2g y minus y0. We're going to start there. Now, this time we can't say that v is equal to 0 because we are at some point here not at the apex, not at the maximum height. Okay? But what we do know about v is that it has to be 1/2 of the original speed. So we can also say that v is 1/2 of the original speed. Now, in this case, probably should make some little subscripts. We'll go v1/2. Alright? Because that's the new thing we're looking for. So if this new final speed is 1/2 of the original, I'm going to substitute that into my equation, solve for y, and find out the relationship here. So we will have v0 over 2 squared is v0 squared plus 2g, y not being 0 again, 2g times y. At this point, I'm going to go through and we're going to solve for y, starting off by squaring what we have here. We've got v0 squared over 4, negative, nope, is equal to v0 squared plus 2gy. Sorry, I forgot my little subscripts there. At this point, I need a new board. I'm simply going to rewrite what I had before. Remembering my new subscript this time. Next step is going to be to subtract v0 squared from both sides. So 1/4 of v0 squared minus v0 squared is going to give us a negative 3/4 of v0 squared is equal to 2g y. Solving for y, I'm going to divide both sides by 2g again. And I'm left with y to the 1/2. Now, we want to be careful here because it's very tempting to just take those numbers and simplify them and make this 3/8 of that. But what I want to do instead is I want to factor out this 3/4. So, let's do just that. We've got y 1/2 is equal to 3/4. And when I factor out the 3/4, I'm left with negative v0 squared over 2g. Which, when I look back at our original basis for comparison, we see is the maximum height. Negative v0 squared over 2g. Alright, I forgot what I got there. That's okay, I'm not typing this one again. Alright, over 2g is just what we got here. So we can say that the height at which it has half of its original speed is 3/4 of the maximum height. Cool beans? Cool beans.